Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today we are going to discuss about the concept of concurrency control in transaction management. Concurrency control in transaction management. So before going to explaining about concurrency control, we already said that concurrent transaction management. So what is meant by concurrent transaction management or concurrent execution in transaction management? So in the transaction management, multiple transactions are executed at the same time. Multiple transactions are executed at the same time. So that is nothing but concurrent execution. But for concurrent execution, we are facing some problems like read or write problems. So to avoid the problems, to stop the problems, we are going to use the mechanism called as concurrency control. We are going to use the concept called concurrency control mechanism. So what is meant by concurrency control? Actually, it controls the concurrent execution. It controls the concurrent execution. So concurrency control is the working concept that is required for controlling and managing the concurrent execution of database operations and avoiding the inconsistency in the database. So that means whenever you are performing the transactions, all the transactions are going to be executed at the same time, but for that same time of execution will leads to inconsistency of the database. So to avoid that one, to stop that one, we are going to implement this concept. Concurrency control is for controlling and managing the concurrent execution of the operations. So what are the operations? You can say that insert operation, update operation, delete operation, and all the database operations such as DML operations, DDL operations. So as for maintaining the concurrency of the database, we have the concurrency control protocols. We have the concept called concurrency control. So to implementing that concurrency control mechanism, we use some protocols. So what are the protocols? So the protocol means it maintains or it exhibits the rules and regulations followed to implement the transaction management. So the concurrency control protocols ensures that atomicity, consistency, and isolation and durability and serializability. So these are all, you can say that transactional properties. One is atomicity property, consistency property, isolation property, and durability property, serializability property. So these are all the transactional properties of the concurrent execution of the database. So these all the protocols were implemented with the help of all the transactional properties. So based on that, these protocols are categorized as: first one, log based concurrency control protocol. We can simply say that log based protocols. And the second one is timestamp concurrency control protocol. Simply we can say that timestamp protocol. And validation based concurrency control protocol. Simply we can say that validation based control protocol. So these are the protocols that are implemented with the transactional properties, and these all the protocols are used to control the concurrency execution. That is nothing but concurrent execution in transaction management. So first of all, log based concurrency control protocol. So what it will do actually? What the protocols will do actually? So these protocols will use the concept of logs while using the transactions. This protocol use logs concept to apply the properties on transactional management. And timestamp concurrency protocols. Here we can use the timestamp values to control the concurrent execution. And validation based concurrency control protocol. Here the database is going to be validate the queries or validate the transactions that you are going to execute on the transactional management. So here the first one is log based concurrency protocol. Log based protocols. So in this type of protocol, any transaction cannot read or write data until it acquires an appropriate lock on it. That means in this protocol, in this type of protocol, any transaction want to execute, before it is going to be executed, the transaction has to acquire some locks. The transaction has acquired some locks. After acquiring the locks only, it is going to be perform the read or write operation. Read or write operation on the data. After read or write operation of the data, performing of all these operations, the transaction is going to be release that lock. Transaction is going to be release that lock. That means the transaction is holding the lock when it is performing the transaction or execution. After utilizing it, after executing it, it is going to release the lock. It is going to release the lock. So here we can use the two types of locks actually. One is a shared lock and the second one is exclusive lock. So shared lock is nothing but it is only a read-only lock. That means you are not going to perform any insert operations or update operations. It is only for read-only purpose. It is only for read-only purpose. So in a shared lock, the data item can only read by the transaction. The data item can only read by the transaction. It can be shared between the transactions because when the transaction hold a lock, then it can't update the on the data item. So if you want to perform an update operation of the transaction when it holds a lock, at that time it is not possible. But after releasing the lock from the transaction itself, you are going to perform an update operation. That is only readable purpose. So this is called as shared lock or read-only lock. And exclusive lock. In this exclusive lock, the data item can be both read as well as written by the transaction. So here we can perform both read and write operation. So this lock is exclusive, and this lock multiple transactions do not modify the same data simultaneously. So here the exclusive lock is for only read purpose as well as write purpose, but shared lock is only for readable purpose. So here you can do the performance, you can do the operations like read operations as well as write operations. But in the shared lock, you cannot perform the write operations because it is only in read only mode. Right? This is the two types of locks in the lock based protocol. So here we can have different types of locks protocols available. The first one is what? Simplistic lock protocol. So it is the simplest way of logging the data while transaction. That means the transaction has a lock. The transaction holds the lock. After finishing the transaction, the transaction is going to be release the lock. So before initiating the transaction, it acquires lock. After finishing the transaction, it releases the lock. So that is the simplistic way of lock protocol. And this simplistic lock-based protocols allows all the transactions to get the lock on the data before insert or delete or update on it. So if you want to perform any operation before it acquires lock, it is not possible. After acquiring the lock, after releasing the lock only, you can perform anything. So that is the simplistic lock protocol. So it will unlock the data item after completing the transaction. That means if you are performing any of the transaction like insert operation on the transaction or delete operation on the transaction or update on the transaction, at that moment the locks is on hold with the transaction. So until and unless it does not complete that operation, the lock is not going to be released. So once the operation is completed, it will unlock the data item after completing the transaction. And second one, pre-climbing lock protocol. So pre-climbing lock protocols evaluates the transactions to list all the data items on which they need locks. That means whoever the transactions are required to use the locks, they have to intimate before initiating that execution of transaction. Only it requests a DBMS for all the locks on all those data items. That means if it wants to perform any operation, if it wants to perform any execution, before initiating the execution of the transaction only, it has to take the permission from the DBMS. It has to take the permission from the DBMS about locks. So if all the locks are granted by the DBMS or by the DBMS administrator, then this protocol allows the transactions to begin. So if until and unless it doesn't have the granting the permissions, it does not able to have the locks and it acquires the locks. So after acquiring the locks only, it is going to be performing, it is going to be executing. So this is the diagram, shows that the transaction before the transaction once started, the lock is attained to the transaction. Once the transaction is initiated for the execution, the lock is attained. So this is all the performing, this is all the transaction is executing. After completion of the execution, the lock is going to be released at the end of the particular time. So before execution of the transaction, it is going to be use the locks. After finishing the transaction, the lock is going to be released. So this is about the pre-climbing lock protocol. And the next one, two-phase locking protocol. Two-phase. So here the two-phase locking protocol divides the execution phase of the transaction into three parts actually. So one is the transaction begin to lock is attained, and the second one lock attained to the execution of the transaction, and third one execution of the transaction, finishing the transaction to lock is released. So there are three phases. First one is what? Begin transaction to lock the transaction, and the second one locking the transaction to executing the transaction, and third one finishing the transaction to releasing the lock. So here there are three phases. The first part, when the execution of the transaction starts, it seeks permissions for the lock it requires. So as like the pre-climbing protocol, it seeks the permission from the transaction, DBMS to acquire the lock for the transaction. In the second part, the transaction acquires all the locks, and the third phase is started as soon as the transaction releases its first lock. So in the third phase, the transaction cannot demand any new locks, it only releases the acquired locks. So already acquired locks are going to be released at now. So this is the two-phase locking protocol. And the fourth one is what? So before explaining about the fourth one, here the two phases are there. Those one is growing phase and the shrinking phase. So growing phase is nothing but what? In the growing phase, a new lock on the data item may be acquired by the transaction, but none can be released. That means it is requiring for new lock to on the transaction, but it is not going to be released using the lock. But in the shrinking phase, existing lock held by the transaction may be released, but no new locks can be acquired. So it is releasing the existing locks, but it is not waiting for the new locks. But in the growing phase, it is requesting for the new locks, but it is not acquiring. It is not going to be released the existing locks. So this is the growing phase and the shrinking phase. So in the below example, if lock conversion is allowed, then the following phase can be happen. So upgrading of lock from S of A to X of A is allowed in growing phase. So here in this diagram, if you can see here, the lock is attained here, and here the lock is released, and here the lock is released, and here the lock is attained. So that means this is a growing phase. In this growing phase, the lock is attained, but it is not requesting for the new locks. But here the lock is requesting for the new locks, and existing locks will be released. So this is the growing phase, and the above diagram shows that growing phase step 1 to 3, and shrinking phase from step 5 to 7. So this is for the transaction 1, and similarly you can see transaction 2, growing phase from step 2 to 6, and shrinking phase from step 8 to 9. So here unlocking the transactions, and here the locking the transactions. So these are the two-phase locking protocol, and here the strict two-phase locking protocol. here strict two-phase locking protocol. So this is somewhat different than the two-phase locking protocol. The first phase of strict 2PL is similar to 2PL. In the first phase, after acquiring all the locks, the transactions continues to execute normally. The only difference between two-phase locking and strict two-phase locking protocol is it does not release a lock after using it. But strict 2PL waits until the whole transaction is to be committed. So the main difference is what? The two-phase locking protocol is going to be release locks without committing the transactions. But the strict two-phase locking protocol, the transaction has to be committed. After that only the transaction is going to be release the locks. So and then it releases all the locks at the time. So strict 2PL does not have shrinking phase of the lock release. So here you can see the diagram. The transaction is going to be started. The lock is attained here. After that, the execution of the transaction is going on. At particular moment of the time, it is going to be released after committing the transaction. After committing the transaction only, it releases the locks. So it does not have any cascading abort as two-phase locking protocol does. So it does not have any cascading abort. So this is the difference between two-phase locking protocol and strict two-phase locking protocol. The next, timestamp ordering protocol. So timestamp ordering protocol used to order the transactions based on their timestamps. That means it decides the logical counter or system catalog are going to be designs the timestamps for the transactions. So based on the time only the transactions are going to be executed. So here the timestamps will be allowed to execute the transactions. So the order of transaction is nothing but the ascending order of the transaction creation. So ascending order of the transaction creation, that means whoever the transaction comes first is going to be executed first. Whoever comes for the transaction is to be executed first will be executed first. Whoever comes the transaction is last will be executed last. So that is nothing but an ascending order way. So the priority of the older transaction is higher. That's why it executes first. So the older transaction, whoever the transaction comes first, that will execute first. So here that's what we are saying here. And to determine the timestamp of the transaction, this protocol uses system time or logical counter. It maintains all the timestamp values for the transactions to be executed. The log-based protocol is used to manage the order between conflicting pairs among the transactions at the execution time. So this actually log-based protocol uses for the attaining the locks for the transactions to do not appear in conflicts. But timestamp-based protocol start working as soon as transaction is created. So as soon as the transaction is going to be started, at the time itself only the timestamp protocol is allowed. The timestamp based protocol is started. So let us assume there are two transactions. One is T1 and the second one is T2. Suppose the transaction T1 has entered the system at 7 times. That means it is appeared for the first time, and the transaction T2 has entered the system at 009 times. So T1 has the higher priority, so it executes first and entered into the system first. So the timestamp ordering protocol also maintain timestamp of last read and write operation of the data. So here we can see some of the conditions of the transactions. So here check the following condition whenever the transaction T1 or T2, the here I stands for 1 or 2 or something, and is use read operation or write operation. So if write operation of the timestamp value of the transaction is greater than timestamp value of the transaction 1, then the operation is rejected. That means whoever comes last for the transaction is to be executed, will execute next, will execute last. So whoever comes for the first for the execution, they will execute it first. So that is what the condition says that. So here a write operation of the timestamp of x less than or equals to timestamp of the transaction, then the operation is executed. So the same way, check the following condition for write operation. So here the timestamp of transaction 1 is less than or equal to or less than read operation of timestamp of x value, then the operation is going to be rejected. Similarly, write operation of timestamp value is also rejected. So this is the some conditions, timestamp ordering protocol conditions are going to be used for the transactions to be executed. So where in the above diagram we can mention that the timestamp of transaction 1 or 2 denotes the timestamp of the transaction, and here denotes the read timestamp, and here denotes the write timestamp, and advantages of disadvantage. So here the diagram shows that this is the smaller one and this is the larger one. So this is the larger one and it executes first. And this is the smaller one, it executes next. So this is the image we can see here. So, the TS protocol ensures that serializability since the precedence graph is as follows, and it ensures that freedom from deadlock, that means no transaction ever waits. So it shows that there is no deadlock situation occurs to wait for the longer time, more than hours and more than years. So but the schedule may not be recoverable and may not be even cascade free. The schedule may not be recoverable and may not be even cascade free. And the next one is what? Validation based protocol. So validation phase is also known as optimistic concurrency control technique. OCCT. So in this validation based protocol, the transaction is executed in the following three phases. One is read phase, second one is validation phase, and the third one is write phase. So read phase, the transaction T is read and executed. So in this read phase, the transaction is going to be read and executed. It is used to read the value of various data items and stores them into temporary local variable actually. So all the readable transactions are going to be stored at particular place called temporary local variables. It can perform all the write operations on temporary variables without an update to the actual database. So in the validation phase, the temporary variable value will be validated against the actual data to see if it violates the serializability. So that means it violates the serializability means it maintains the order or not. The whoever comes for the first, they will execute. So they are maintaining the serializable concept or not. They are having interleaved or not. So that is the phase, validation phase. And the write phase. If the validation phase of the transaction is validated, then the temporary results are returned to the database or system. Otherwise, the transaction is going to be rolled back. So it checks that the validation phase is completed, then only it performs the write operation. So here each phase of the following different timestamps. So start of transaction, it contains the time when TI started its execution. So it started whenever the transaction is going to be started. So validation, it contains the time when transaction is finishes, it reads phase and starts its validation phase. It's read phase and starts its validation phase. So it checks that the executed transaction is available in the local variables or not. And finish, it contains the time when TI finishes its write phase. So whenever transaction is executed, at the moment of the finishing the transaction, it is validated, then it is going to be finishing. It is validated, it is going to be finishing. So at that moment, the finish operation or finish phase is executed. So this protocol is used to determine the timestamp of the transaction for serialization using the timestamp of the validation phase. So as it actual phase which determines if the transaction will commit or roll back. The transaction is commit or roll back. Hence, we can say that the timestamp of transaction equal to validation of transaction. The serializability is determined during the validation process. It cannot be decided in advance. So while executing the transaction, it ensures a greater degree of concurrency and also less number of conflicts. So thus it contains transactions which have less number of rollbacks. So in this we are saying that what validation protocol. So read phase, first of all, the database is going to be read the transactions which are going to be performed. So all the transactions are going to be execute the first read phase. So once the data items are read by the transactions, all are going to be stored in the particular temporary local variables. So now in the validation phase, the actual data is going to be validated against with the temporary stored data. If the data is validated, the stored data and database data is validated, then it is going to be perform write operation. So if the validation of the transaction is validated, then the temporary results are going to be write on the database itself. So for this we are using these phases: start phase and validation phase and finish phase. So this is about this validation protocol. So in this session what we are going to see all the different types of concurrency control techniques here. The first one is what? Concurrency control definition. So concurrency control is the working concept that is required for controlling and managing the concurrent execution and of the database operations. So for that we are using different types of protocols. One is lock based protocol, second one is timestamp based protocol, and third one is validation based protocol. But lock based protocols are working with the help of locks. So they are using locks to apply the transaction, hold it and release the locks. So before going to executing the transaction is going to be acquires locks. After executing the transaction only, the transactions are going to be release the locks. So this is the concept behind these lock based protocols. And next one, timestamp concurrency control protocol. So in the timestamp concurrency protocol, the control protocols are helping that based on timestamp. They are going to be executed based on the time values or timestamp values. So under validation based control protocol. So here the database is going to be validated the stored values in the temporary variable with the actual database values. So once it is confirmed, then they are going to be used the write operations. So here first lock based protocols, we are using two types of locks. One is shared lock, second one is exclusive lock. But shared lock is only for the read only purpose. So you are not going to perform any write operation or insert operation or update operation on it. So shared lock is only for read purpose. But in the exclusive lock, the data item can be both read as well as written by the transaction. So here this is not a read only purpose. It can execute for the read operation as well as write operation. And based on this, we are going to provide four types of locks actually. So first one is what? Simplistic lock protocol. So in the simplistic lock protocol, what we are going to say, simply the transaction is going to be performed or executed. So before it is executing, the transaction holds a lock. After finishing the transaction, it releases the lock. And the second one is a pre-climbing lock protocol. So here, the pre-climbing lock protocols, whenever the transactions are going to be acquire locks or update the transactions or insert the transaction, the inserting operation or updating operations are doing within and only the locks are obtained. The locks are attained in the transaction. So without having the permissions, without having the granting permissions of the lock protocol, the transaction is not going to be use these locks. use this lock. So pre-climbing protocol, and this diagram shows that the lock is attained before after beginning the transaction. After beginning the transaction is going to be executed. Once it is executed, lock is going to be released at particular point of time. And third one is two-phase locking protocol. So here the two-phase locking protocol says that it is going to be used three types of phases. One is beginning of the transactions to executing the transaction. Second one, executing the transactions to finishing the transaction, and finishing the transactions to releasing the locks. So here the two phases are, one is the first part is begin to executing, and second part is executing to releasing the locks. Up to this two-phase locking protocol. But here the locks are released without committing the data, without committing the transaction. The locks are going to be released without committing the data. And here there are two phases in this two-phase locking protocol. One is from growing phase and the second one is from shrinking phase. So growing phase shows that a new lock on the data item may be acquired by the transaction. It requires for a new lock, but it cannot be released. So it is requiring for new locks, but it cannot be released. But shrinking phase, existing lock held by the transaction may be released, but no new locks can be acquired. No new locks can be acquired. So it is not going to waiting for the new locks. It is not going to be waiting for the new locks, but it is releasing the existing locks. It is releasing the existing lock. So this is some conversion between those growing phase and shrinking phase. So this diagram shows that particular transaction, particular phases, it is going to be obtained the lock and it is going to be released the lock. So for a particular point of time, the lock is going to be attained here and the lock is going to be released here. Similarly here from this phase, lock is attained and here lock is released. Lock is released. So and last one, strict two-phase locking protocol. Strict two-phase locking protocol. So here the same two phases will happen here, but the releasing locks will be after committing the transactions only. The releasing locks will be after committing the transaction. After committing the transactions only, locks will be released. So this is the point of moment. The lock is attained here and the lock is released here after committing transaction. After committing the transaction, the lock is going to be released. So this is the strict two-phase locking protocol. And this one, timestamp order protocol. Timestamp order protocol. So here for all the transactions they are going to be maintained some timestamp values. The timestamp values. So after utilizing the timestamp values only, it uses the read or write transaction. Read or write transactions. So here in this we are going to say that all the older transactions are executed first, younger transactions are executed last. So that means whoever comes for the execution first transactions are going to be executed. Whoever comes last for the execution are going to be executed last. So that is the principle the timestamp ordering protocol will follow here. So the same conditions, some of the conditions for ordering the protocol. So this is the diagram shows that younger transactions are waiting for the next moment and older transactions are executed for the first moment. And validation based protocol. So here all the protocol data is going to be maintained with the temporary local variable, and if it is validated with the actual database, then it is going to be perform write operation to update the database itself. So this is the way we can understand this all the locks protocols in the concurrency control protocols. So concurrency control protocols maintains that all the locking mechanism, timing mechanism as well as validation mechanism. So based on these mechanisms, log based protocols are existed, timestamp ordering protocols are existed, and validation based protocols are existed. So this is the way we can understand from concurrency control techniques using the different types of concurrency control protocols. Right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.